All right, what's up, everybody? I'm back here with another video on Table 1 and Table 2, our descriptive statistics table and our contingency table. So you'll have here, I still have my RStudio open. I'll just show again what happens if you did this in two separate sections. So we're come back here to our load up our ELSA here, start a new server for our RStudio, and wait for it to load up. But the general premise, what we're going to be doing today while that loads, is we're going to create a descriptive statistics table, which is going to show us summary statistics for the two variables that we're going to be looking at in our chi-squared paper. And in our second table, we're going to be looking at the cross tabulation between our independent and our dependent variable. We're specifically going to focus on how to make the tables in this video, a little bit less on how to interpret it and the chi-squared part of interpreting it. I'll cover it briefly, but I'm going to focus more on just creating the tables. And in class, we'll cover more about how to interpret it and what the output more specifically means. But I'll talk here specific how to get the output. So we connect to our RStudio server, and everything crashes again, so it always restarts. And the beautiful thing is here, we should just be able to run all this right up here. And it's gonna be embarrassing if it doesn't work. But it did, yay. All right, so we're on to our next part here. So we're ready to get our descriptive statistics. The nice thing is here, for what we need for the descriptive statistics for this paper, we can actually just continue to use this function here. And I'll explain why that is the case in a moment. So we update it here, use, describe, command, or marginal probabilities in table 1. So one of the beauties about why we made these dummy variables. So first off, let's look at the initial variable, CONEDUC. This shows descriptive statistics for this variable. Right, this is a qualitative or a categorical variable, where each of the values of the categories don't have a numerical meaning. Just because someone has a value of 2 for the variable CONEDUC doesn't mean that you could you can't necessarily do math with that number. You can't say that someone with a value of 3 has someone who's a value of 3 of CONEDUC has one more value, has one more has a value that's one higher of someone with a CONEDUC of 2. That doesn't make sense both theoretically, mathematically, and it also doesn't make sense looking at the actual variable, because the variable measures something else. Ironically, someone with a higher value of CONEDUC actually has less confidence in education. We couldn't say a 3 is one more confidence than 2 when 3 is actually less education. And it's not really a mathematical value. These are categorical responses. So if we say the mean of CONEDUC, this doesn't make any sense. This is a nonsensical interpretation for this mean. However, when we create the dummy variable for high CEDUC, remember this has a value of 1 for those that have a high level of confidence or a great deal of confidence in those who manage education, and 0 for those who do not have a high degree of confidence in education. Now this mean we can actually interpret. This is a minimum of 0 and a maximum of 1. This is exactly what we wanted for our dummy variables. We wanted it to range from 0 for not meeting the condition to 1 meeting the condition. And the mathematical beauty here is that now this represents a proportion or a percentage. So 18% of our respondents have a great deal or high level of confidence in those who run education in this country. 59% have medium deal confidence, or only some confidence in those who run education, and 23% have a low confidence in those who run education. Now notice here that this should sum to 1, assuming that our variables are mutually exclusive and exhaustive. 18 plus 59 plus 23 should sum to 100%, maybe a little different with rounding, but everybody, what this is saying is that 100% of respondents have a high degree of confidence, a medium degree of confidence, or a low degree of confidence. So, and that makes sense because everyone answered the question. We're looking at descriptive statistics of my data set. Only the people who answered both questions. Okay, same thing we do with high school degree. 47% of respondents have a high school degree. This is 9% have an associate's, 20% have bachelor's, 15% have a graduate degree, and 10% have no high school degree. So same thing. Okay, let's come back here and let's edit this. So this is the template. You can find the template if you go to Canvas, go to Home. I have the templates listed many places, but here's one spot here, and syllabus and course links. So I'm just going to make a new copy of this. I'm not directly changing the one that the template you're gonna get. So I'm just gonna get this one. I'm gonna call it example descriptive table. I'll just make this one while I'm at it here. File, make a copy. Example table 2 squared. So there's instructions that are commented throughout here. But generally what we want is we want to have our dependent variable. Each of the categories are dependent variable. And the mean here, we're going to put the proportion of folks who meet the category. Under description, we're going to provide a description of what the variable represents. I put here green, all the cells you want to edit. So you want to edit all the cells that have green in them. And you don't want the table to be green ultimately. We want our table to look professional at the end, so there's not random green throughout professional tables. So we're going to make this all white once we finish up. So descriptive dependent variable is going to be first CONEDUC. Another thing with our tables, we want our tables to be substantive variable names. Someone should be able to look at this table and understand what is measured inside of your data set, even though they have no idea what's going on in your data. By the end of the semester, you're going to be the expert in the two variables that or all the variables that you're analyzing. You're in the particular data set that you built. Only you may be the only person who's ever created a data set exactly like the one you'll be presenting, and done the exact analysis that you're doing. So you shouldn't expect that anyone. Maybe I'll have a good idea of it, but you shouldn't expect certainly that. But you shouldn't make the table under the assumption that I know what your paper is looking at. You shouldn't do it under the assumption that someone who has no idea what's going on with your paper should be able to understand your tables and figures. So we're going to name our dependent variable a substantive name. Let's call it confidence and education. And we're going to add our categories. Each of our categories also have substantive names. So let's our first category, let's make it a great deal, some confidence, and hardly any confidence. You can use the exact same words that were posted on GSS. We could also use the kind of shorthand we were using before: high confidence, medium confidence, low confidence. Both these are just substantive. Both substantively mean the same thing and are fairly interpretable to a reader either way. Now, we're going to add more rows or categories if there's more than 3. I'll show what this looks like in the next variable, what this means in the next variable. But for this one, there are actually 3 categories, so it's fairly it matches up pretty well. So we can actually go ahead and delete that comment. Does that work? Yeah. All right. So enter means is proportions for each categories. Our qualitative variables should be exhaustive, mutually exclusive. So all proportions should sum to 1. All right, so we'll get rid of that for now. I'll show what this means. So here we want to put the proportion of those that have a great deal of confidence and education. That's right here, 18. I'm going to round all this to 2 decimal places. 0.18, 0.59, 0.23, 0.59, 0.23. So why do we use 2 decimal places? There's really this is the question of how much to round is context dependent. You want to include as much information as is helpful to understanding to describing what's going on with your data, but also not showing that you have too much confidence or in the quality or the level of in the data that you necessarily have. So, for example, if we were to round this to 2 decimal places, we'd say 20% of a great deal, 60% have hardly any confidence, 20% have hardly any, 20% have great deal, 60% have some confidence, 23% have hardly any. That seems to be cutting off a good amount of information. For example, it may be important to realize that there are more respondents who have hardly any confidence than those who have a great deal. So I'll show if we round this to 1 decimal place. I can actually, if we highlight this, we can go like that. This will be down to 2 decimal places. Similarly, if we go to 3, does it really matter if there's a big difference between 18.2% who have a great deal of confidence and 18.5% that have a great deal? Is that really something that is worth that is going to add that much information to our understanding of Americans' confidence in education? I would argue in this case it doesn't really tell us that much. And moreover, we're not talking about a census of every single American's confidence education. We're just talking about a sample of a couple thousand, which has its own biases and may not be 100% accurate to begin with. So maybe it's a little it's probably it might be expressing a little bit too much confidence to include 3 decimal places in this situation. It doesn't really add any value or information to the reader. So generally, we'll keep our descriptive statistics rounded to 2. If you have a quantitative variable, there may be a reason for otherwise. Well, again, it's context dependent, but for this class, round all of your descriptive statistics to 2 decimal places. Now we're going to put descriptions. How much confidence R has in people who run education in USA? Great deal of confidence. 1 equals yes, 0 equals no. So when we're doing descriptions for our dummy variables, we always want to specify what is 1 and what is 0. Some confidence. 1 equals yes, 0 equals no. Hardly any confidence. 1. And you want this to be very cleaned up. So see, I capitalized here. You want to be consistent. I am very nitpicky on tables, just as a heads up. And we'll talk a lot about tables as the paper goes. For this first assignment here, it's okay if there are some little thing. It doesn't have to be perfect, but I am going to be more picky when it comes time to handing in full papers. 1 yes, 2 no. So like maybe want to capitalize. We're going to capitalize that. We should probably capitalize yes and no. All right. We would not want to capitalize any. It's not up or down. Okay. All right. Well, I'll come back and think a little more. You want to be careful about what you're capitalizing, what you're not. Be consistent with that. But for now, let's come down. So this is how we did 1 variable. Halfway down our table 1. Table 2. For our next variable. So this is where it would matter how many categories. First, I'll show. Let's say we wanted to use every single category as separate. So this is going to be degree. We'll have no high school. Again, substantive variable names. High school. I say category K means include as many rows as numbers of categories. So there's going to be 5 categories. We're going to need to insert more rows. Associates, degree, bachelor's, degree. Then include trade school again. I can't remember. Let's go back. We'll check, make sure we're being or junior college. Okay. And graduate. And we're going to delete this bottom row here. This one. You keep that line at the bottom of the table. Let's resolve these guys and put it in. So we have our no high school. We're going to have 30, 50, 28, 40, 35. I already forgot all those numbers. 30, 50, 28. 40 and 35. That's a really large proportion of people with bachelor's degree. Notice here it may automatically round for you if you didn't add it. If you didn't give it a second digit, it's going to automatically round up. So maybe you can highlight those cells and make sure you tell it to round to 2 decimal places so it's consistent. One thing I'm very picky with in tables is you want all of your decimal points to line up. All these decimal points line up in this column. That's makes it look cleaner, makes it look a lot more professional. A lot of making tables is more of an art than a science, but it's a very heavy. How professional and how good your tables look are a strong signal of the quality of your work that people use for better or for worse to judge how much you know what you're talking about. I don't make the rules. That's just how people do it. People like to make your stuff look pretty. And I say pretty, I mean professional, which has its own. We'll talk a lot about this. I'll go into off the deep end on this in this video here. All right, so degree here, highest degree named by R. I use R to just mean respondent. R has no high school. R has a high school degree or equivalent. So we want our variable names to be as short and substantive as possible. And we want our description, we can have a little more value, a little more information. R has an associate's junior college. R has a bachelor's degree. R has a graduate. Okay, so now this is if you want to include every category. Let's say we actually are, we only really wanted to use college grads, those who don't have a college degree. We really thought that was our primary interest. In that case, we're going to limit this down. And we want to only include the we only want to include the one category. Well, we want to limit down the rows that are listed here. Now, the beauty of a qualitative variable that you simplify down to only a dummy variable. So this one dummy variable represents the whole variable for degree. College grad. Is that we actually can just, we don't even need the whole variable and underlying, we don't need a whole variable and underlying categories like we did up here. We can actually just make it all into one single row. So we call this, we'll just call it college 4-year degree. R has a bachelor's or graduate degree. 1 equals yes, 0 equals no. You want if you would have kept all these as dummy variables down here, you'd also want to have the one yes, 0, no as well. So I don't want to show this here. So now we are going to actually add this, put the proportion here, and it's 0.35. I knew I had an error back here, just to show what this was. This was not right. This was 0.2, and I could have confirmed that by highlighting all of these and seeing the sum is well over 1. So that was an indication that I made that mistake back there. But yeah, so yeah, that would not have made sense. 35% of people have a graduate degree. Yeah, that didn't make sense. All right. Anyway, we'll go forward. All right. So I want to know the bachelor's or graduate degree. Got that back here at 0.35. That's the one I accidentally copied as graduate. Yeah, okay. 0.35. Now here we say n equals sample size here. Well, good guess. We're going to put our sample size where it says sample size here. 2758. Or we'll put the sample size of our complete case information. 2758. All right, so let's clean this up a little bit. We want to get rid of our green. Green doesn't make I do love the Eagles, but we'll keep it out of our table here. We'll put a border here at the bottom. Maybe extend this out a little bit so it's matching. Let's indent these a little bit so it's very clear they're subcategories. Right click. I'm used to working in actual Excel. We'll see if we can find a way. We want to indent it a little bit. Format alignment. No. Usually a way to just like indent a little bit. Should be indent button. All right, well, it's here. Rather than having you watch me go through all these comments here, I'm just going to add a couple spaces at the beginning. I added 3 spaces before each of the categories. Now it's very clear that these are 3 subcategories of this underlying variable. I'm going to do the same thing for each of these descriptions here, so we can see that. Another thing that's actually a good little we're going to say R has a bachelor's degree. For this description, we should probably say for all of them. Okay. All right, this isn't perfect, but hopefully you got a good sense here. Oh yeah, definitely a comment there. All right, this is a good little start on our here. I'll actually just call this example tables, so we can have all one. I'll post this on Canvas so you can see what the example looked like. All right, well, now I'll just take this guy here. I'm going to bring it back into our example tables. All right, so again, here we're going to do the same thing for our table 2. We're going to edit categories. We're going to edit the stuff that's in green. We're going to fill it in. Those who have taken a stats course, well, everyone should have taken a stats course before and seen something that looks very similar to this. But I'm going to walk through as if you haven't seen a crosstab or a crosstab before here. Again, we'll talk more about the math and where all this comes from in class, and we'll practice a lot of it. But I want to, in this one, I'm more going to focus on how to make this video, how to make the table. Sorry. All right. So first, we're going to change our table here. We want to have our title instead of IB and DB that's in green. So we're going to change that to our independent variable, which is 17 college degree. Call it 4-year college degree, and our dependent variable, which is trust in education. And we're going to put our independent variable as the rows and our dependent variable as the columns. So independent variable is 4-year college degree. Actually, before we even get to this table, let's go back to R and make the output for it. So coming back here, now what we want to do is we want to look at the relationship between whether a respondent has a college degree or is a college grad. In other words, they have a bachelor's, a 4-year degree, they have a bachelor's or a graduate degree, and whether or not, and their level of confidence in education. So to do that, we're going to create a crosstab, similar to what we did when we were cleaning variables between our between these 2 variables, where the first variable we're going to list is our independent variable. Our independent variable is going to be college grad. The second variable we're going to list is going to be equal to our dependent variable, which is going to be Con-C. So how do we read this again? This first row here is those who have a college degree. For those who do not have a college degree, so they do not have a 4-year degree. This is those who do have a 4-year degree. Each of these, this is those who have, everyone in this column has a great deal of confidence education, some confidence education, hardly any confidence in education. These 330 people do not have a 4-year degree, and they have a great deal of confidence in education. These 1031 people do not have a college degree, and they have some confidence in education. These 441 people, respondents, have no 4-year degree and hardly any confidence in education. So notice here, when just looking at this value here, it can be a little, it's just looking at these numbers here. Want to know well, you could start to, if you wanted to know the relationship between them both, you'll realize it can be a little tough to interpret it just off the bat. For example, there are more people without a college degree who have a great deal of education than those who have a college degree and a 4-year degree and a great deal of confidence in education. However, there's also just more people generally who do not have a 4-year degree. So how much of the fact that this 330 is greater than 177 is because people with out of college degree have greater confidence in education, and how much of it is just that there's more folks without a college degree. Because similarly, there's 441 people without a college degree who have hardly any confidence in education, compared to 188 people that do have a 4-year degree and have hardly any confidence in those who run education. So there's also more people who do not have a degree. So there are simultaneously more people who do not have a 4-year degree that have a high degree of education, and there's also more people who do not have a college degree and have hardly any confidence in education. So we're going to use row percentages to help us make sense of this. And you probably talked a lot about this in previous classes, but we're going to use row percentages in our table for this class to make sense of this relationship. All right, so going back here, let's just call it 4-year degree. We'll make this a little bigger here, not that big. And our dependent variable is going to be confidence in education. Similarly, we're going to add or subtract rows depending on how many confidence or the level of 4-year degree. So if yes, where they do have a 4-year degree, and no, if they do not, we're going to get rid of these other rows. So I added rows. We're going to delete rows. For confidence education, we're going to have high. We want to use the exact same values that we used back here. Great deal. Some confidence, some. There we go. There should be. We're going to say right confidence. We should write it for all of them. Great deal. Some. Hardly any. In fact, I think I'm just going to cut this back to high, medium, low. Make this easier to remember what the heck these things mean. High, medium, low. We get rid of this extra column here. And then here we're going to put, first we're going to put these values here that we just had. 330, 1031. $441, 188. Notice I'm putting them in the not the row percentage yet. 177, 591. Okay, so now we have our table here. So first thing we're going to fill in is our row total, which is all of those who have yes to a 4-year degree. There are a few spots we've seen this. We've seen this before already with the table we did. We could use the proportion we calculated earlier. We can even just do a base table for each of the variables independently. Okay, so we know it should be 956. There are 956 people who have a value of 1 for college degree. Let me confirm that right here. Oh, wait a second. Here we go. Where degree? Oh, what happened here? College grad. Oh, I'm silly. This is one. No, yes. Good catch. So no's always going to list first. One's going to be listed second. This is a good thing to keep going through and checking where your values are. This is where our 956 is. So there are 956 people who say yes to a 4-year degree. Similarly, there are 1802 that say no, having a value of no for 1802 for that. We can see that. We highlight down here, look down here for the sum. We can also look at this sum, the 2458. This should be our sample size. Why is it not? What did I do here different? 1802. I'm silly. See, found another error myself. 1802. And this should be our sample size. 2758. 758. Sample size. So next, we want to get the row percentage. So the row percentage is among those in a given row, what percent of folks are in a category. So to do that, we're going to take our row percentage, or our cell count, divide by our row total. So we did it mathematically in Excel. We do C4 divided by, and I'm going to put a dollar sign here to say to hold at F4 right here. But you don't actually have to do it. You can also just calculate it out manually. And we're going to get around 18%. So we can also do this manually. 330 divided by 1802. Maybe type in enter at the front of an Excel it'll give you that proportion. Now the benefit of putting this dollar sign here is that I can drag this across. Now in this one here, it's still using F4 as the denominator in this equation. So the dollar sign saying hold that cell. And we're going to run around this. Oh, I'll show it. First we'll do these. So this is a proportion first, and we go from proportion to a percent. Actually, this you can even do it right inside the right side of this by multiplying it by 100. So similarly, all of these percentages should sum to 100%. Actually, instead of doing that, I'll go back. Instead of multiplying by 100, there's a few ways you get it to look like this. I'm just going to highlight these proportions. I'm just going to click the percent sign right here. I only want those formatted as a percent, just these. It's going to move that to a percent. So automatically will multiply by 100. But either way, proportions sum to 1, the same as percentages sum to 100%. You can check this 100%. This is 100%. Okay. We'll do the same thing down here. I think I actually maybe want to copy this thing right here, see if it works. Nope, it's going to use F4 again. So we don't want it to be F4, we want it to be F6. Our denominator is correct. Sum those over here. This is 100% from this equation, 591 divided by 956. Okay, so now how do we interpret these percentages? What this means here, it's 18.3, means that among those, so always start your conditional statements with the word among. You can also use given or of, blah, blah, blah. There are many ways to specify a conditional statement, but in this class, always say among. Among those without a 4-year degree. 18% have high confidence in those who manage education. Among those without a 4-year degree, 57% have medium confidence in education, and 24% have low confidence in education. Similarly, among those with a 4-year degree, 18% have high confidence in education, and 61% have medium confidence education, and 20% have low confidence in education. So now we can, looking at this, we can start to compare some of the percentages. Again, we'll do a little more of this in class, but I'll just give a couple examples. Seems like both those with and without a 4-year degree are equally likely to have a high degree of confidence in education. However, those with a 4-year, the one difference we're seeing is that those with a 4-year degree are more likely to say medium than low relative to those without a degree. In other words, those with no degree are more likely than those with a 4-year degree to say that they have low confidence education. Okay. So these are just the absolute differences. In fact, they're around 5%. There's a 5% gap here. So those who do not have a 4-year degree are 5% less likely to say they have a low degree of confidence education than those who do have a 4-year degree. Okay. So we can come back here. We can see this. We can actually do a test. We can say, well, is this relationship, are these differences we're seeing, this 5% difference, this 3% difference, this 0.2% difference, this one's very small, this one, 4 or 5%. So this is whether or not those differences are practically significant is up to you. In other words, is this difference here actually important or not? That's not a statistical question. That's a substantive or theoretical question. Is this actually showing any differences? That's it's not just up to you. I mean, it's an argument that you can make, I should say. It's not just like it's not purely subjective. It's an argument you can make. However, we can ask whether this relationship is statistically significant. And what that's going to ask is, are these differences we're seeing, how confident are these differences we're seeing? How confident are we that these differences are actually real in the population of everyone who lives in the United States? And versus what is versus the chances that it just occurred completely by chance? We only looked at 4,000 people in the United States. We didn't look at everyone in the United States. Every time we talk to 4,000 people, they're going to be different. There's 4,000 people. Ideally, we can generalize from them to the population of everyone in the United States, but there's some degree of uncertainty there. And when we can test is this relationship statistically significant? What this is going to tell us is how confident are we that these differences we're seeing in our sample are actually existing, that there's actually a difference in the population. And we do that with the chi-squared test. And the beauty of the chi-squared test, we just throw the table right inside of it. And interestingly here, oh wait, actually, no, this is right. Yeah. And what this is saying here is this point P equals 0.01. This p-value is the probability that we would have observed differences that are at least this extreme. So it's the probability we would have observed percent differences, these row percent differences, or at least this extreme, if it was the case that there was no relationship between college grad and EDUC. So if there was no relationship between whether someone had a 4-year degree and their confidence in education, there's a 1% chance that we would have observed these data, or we would have taken this sample. So it's fairly unlikely we would have observed this data. In other words, we can be fairly confident that there is a statistically significant relationship between college grad and confidence in education. The general cutoff we'll use in this class and is used across the board is a p-level of 0.05. That means that there's around and if the p-value is less than 0.05, that means there's a less than a 5% chance we would have observed this sample or these data here that we collected if there was actually no relationship. So we're fairly confident there is a relationship. All right. I'll slow down on all that. We'll talk more about these chi-squared values, how all this comes, but the general thing we're looking here is this p-value, the summary. And here it looks like this is a statistically significant relationship. Practically significant, a little different. All right, let's get this table cleaned up, looking a little more professional. We're gonna use black ink. We're gonna get rid of our green highlighter. Gonna make sure this row here at the bottom, this line's still here. Is this font? Am I using different font for some reason across the board here? Somehow we're using different font. Make sure we're using the same font we're using in our paper. The same text size. Is that the same font size? Okay. So in these percentages here, notice our decimal points don't line up. So let's take these percentages here, and we're just going to round them to whole percentages. That way they line up. There's no decimal places that are misaligned here. If you want to get real fancy, we can add a couple spaces here. See if we can get it to exactly match up with 18. So the 1 and the 8 line up. I need to play with that in the formatting. You usually play with the formatting to get the 30-30 and the 18 line up as well. So like the 1s line up as well. I would not recommend that, but yeah, options. So make sure we have commas. We're gonna use commas. I'm not seeing any errors off right now, but please let me know if you see any errors, and I will be sure to fix them up. But yeah, so this is how you make your table 1 and table 2 for your chi-squared paper. Please let me know if you have any questions or suggestions for how to make this video better or how to make future videos better. And thanks for your hard work. I'm looking forward to hearing all about the interesting relationships that you all find between the variables that you're taking a look at this semester. Thank you and have a good rest of your day.